And now we begin subnetting video number 2 of 4. There are 4 subnetting specific videos. This video will cover network address, broadcast address, and usable range. Learning objectives. After concluding today's training, you will understand the following. What bitwise AND operation results in 1? What bitwise AND operation results in 0? What does the network address identify? What does the broadcast address identify? What does the usable range identify? How is the network address determined? How is the broadcast address determined? How is the usable range determined? With regards to ARP, what should happen when host X is attempting to communicate with host D in a different subnet? With regards to ARP, what should happen when host X is attempting to communicate with host Y in the same subnet? Why do you need it? That's a good question. Well, by knowing the network address, broadcast address, and usable range, one can make informed decisions when evaluating what a host will do on the network. Namely, one will be able to determine whether or not IP addresses are within the same subnet as a host, which affects what IP addresses the host will ARP for. Recall from an earlier lesson ARP that if hosts are on the same network, then the end host will ARP directly to obtain the Ethernet address. If hosts are not on the same network, then the end host will need to ARP for its default gateway. Thus, subnetting is crucial for end host operation on the network. Exercise 1 of 7. Bitwise AND operations. Okay. So for this exercise, we're going to perform a bitwise AND operation. And we have this handy table that tells us exactly what should happen. It says a 0 and a 0 should equal 0, a 0 and 1 should equal 0, a 1 and 0 equals 0, and 1 and 1 equals 1. Bitwise AND operations. So, as we can see, here, this is the result of performing a bitwise AND operation for these two binary values. You get this bitwise AND operation as a result. Bitwise AND operation is important because it's actually utilized for subnetting. Okay, now let us continue to the next exercise. Exercise 2 of 7, find the network address. So, in order to find the network address, you need to be given an IP address and a subnet mask. And you will perform a bitwise AND operation on the IP address and the subnet mask. So, in this case, we're going to find this information and we're given this information, the IP address and a subnet mask. Okay, in the first step, we're going to convert the IP address and the subnet mask to binary. So here we take these decimal address and decimal subnet mask and convert them to their binary equivalents, which you should be familiar with doing by now. So if you feel like you need to pause the video and check to work this out yourself, feel free to do so. In the second step, we're going to perform a bitwise AND operation on the IP address and the subnet mask. Now recall from doing the bitwise AND operation earlier in exercise 1 that only where you had a 1 and a 1 would you get a 1. Otherwise you'll get a 0. So you only have to pay attention to where the subnet mask matches the 1 entries in the network in the IP address. And all these are going to be 0 here, and you see that. And then now you just need to convert this binary back to decimal. Yep, and you convert that binary result to decimal, and that gives you your network address here. In those simple, easy, 3 fun steps. Now, exercise number 3, find the broadcast address. In this case, you've been given the network address and you have the subnet mask, but you don't know what the broadcast address is. So how can you find it? Guess what? We can do that too. So first, we will convert the network address and the subnet mask to binary. You notice, so that's why binary was our first lesson, because it comes into play for subnetting. And you see we convert this network address to binary and we convert this subnet mask to binary. So far, so good. We're going to perform a bitwise AND operation on the network address and the subnet mask. Okay, we've done that. So are we done? Probably not. It only says step 2 of 5, so maybe not. Now it says we need to locate the network and host boundary in the subnet mask. Okay, and that is here. As you recall earlier from the prior lesson, when we covered looking at the subnet mask and we had that VLSM table, and there was an entry in there. There was a slash notation and then there was a decimal number. And that slash corresponded to the number of bits that were network. And the ones left over were host bits. So here is that boundary we're establishing between the ones that are network bits and the ones that are host bits. So we've located this boundary within the subnet mask, because it's that obviously where that subnet mask ends, what the network part ends and where the host part begins. Okay. Now we will convert all the host bits to 1 within the broadcast address. So all these host bits in the broadcast address are turned on. Okay, that was simple enough. Now convert the binary to decimal, and we've done this many times. And now we have what the broadcast address is given this network address and this subnet mask. Exercise number 4, find the usable address range. So to find the usable address range, I like these handy hints up here at the top. It's so handy. So you're given a network address and a broadcast address. Oh, you gave me that much. That's so nice of you. So then you would just flip the last host bit in the network address to 1. That would be the first host. And flip the last host bit in the broadcast address to 0. And that would be your last host. Okay, so we're given a network address and we're given a broadcast address, and we just need to get the first usable address for a host and the last usable address for a host. I think we can handle that. It should be pretty simple. Now, convert the network address and the broadcast address to binary. Okay, binary, binary. That was easy. Locate the last host bit. Okay, that's where the last host bit is. Fairly simple. It's the one furthest to the right would be the last host bit. Now, flip the last host bit in the network address to 1. So I copied everything down and just flipped this one to 1. Okay. Flip the last host bit in the broadcast address to 0. So I copied everything from here up here, except this one got flipped from a 1 to a 0. Okay, that's simple enough. Now convert binary to decimal, and that's something we've done many times by now, and this should be fairly simple for us. So now we have the usable address range. Given this network address and given this broadcast address, the first usable address should be this, and the last usable address should be this. I know you're thinking, hey, couldn't we have just subtracted from the decimal and added to the decimal? Well, knowing this binary piece always comes in handy, trust me. Now, exercise 5. Find network address, broadcast address, first usable, and last usable. So we're given an IP address and subnet mask. Find the network address, broadcast address, first usable and last usable. Wow, you give me a lot. Okay, so we have this IP address, this subnet mask, and we need to find these others. Let's see what we do for that. Now here, first we convert decimal to binary. We're well versed in this by now. So we convert decimal to binary. There we go, we did it. Okay. What's the next step? Perform a bitwise AND operation on the IP address and subnet mask. And because that's what we did before to get our network address. We remember doing this. Okay, that's fun. Okay, now we're performing a bitwise AND operation on the network address and the subnet mask, because now we're actually trying to find this broadcast. But we're not done yet. We also need to locate the network and host boundary in the subnet mask. Very critical, and we did that. Convert all host bits to 1 to make the broadcast. Boom. Now we have the broadcast address ready. But we're still not done because we still need first usable and last usable. Okay. So, okay, locate the last host bit. Okay, it's very easy. It's the one over here. Farthest to the right is the last host bit. This column right here is the last host bit. Flip the last host bit in the network address to 1. Network address, last host bit to 1. Okay. We did it. Flip the last host bit in the broadcast address to 0. Okay, we took this and copied up here and flipped this to a 0. That's our last usable. Okay, we did that. Convert binary to decimal. Okay, we're very familiar with doing this conversion, and we're just doing a direct conversion, and boom, there we go. And this is our answer. For network address, first usable, last usable, and broadcast address. Exercise number 6, subnetting and ARP different network. Given host X and host D are on different networks, and Z is the default gateway. What should happen when host X attempts to communicate with host D? Host X should ARP for the Ethernet address of host Z, its default gateway, and send the frame to host Z. Because host X is trying to communicate with host D, but host D is on a different network. It's in a different subnet. Host X realizes this, so it says, okay, you're not inside my network, so I'll just ask my default gateway to handle it. And that's what host X does. Exercise number 7, subnetting and ARP, same network. Host X and host Y are on the same network, and Z is the default gateway. What should happen when host X attempts to communicate with host Y? In this case, host X should recognize that host Y is within the same subnet. In this case, it should ARP for the Ethernet address of host Y, so it can then send this frame directly to host Y. Learning verification. Oh, this fun part. Now, what bitwise AND operation results in 1? What bitwise AND operation results in 0? What does the network address identify? What does the broadcast address identify? What does the usable range identify? How is the network address determined? How is the broadcast address determined? How is the usable range determined? With regards to ARP, what should happen when host X is attempted to communicate with host D in a different subnet? With regards to ARP, what should happen when host X is attempting to communicate with host Y in the same subnet? These are some important questions right here, trust me. I know you've seen them many times by now. but they're very important questions. Summary. There are 5 pages of summary. Bitwise AND operations, including a 0, will always result in a 0. The only bitwise AND operation that results in a 1 is a 1 and 1. Please note that this is referring to bitwise AND operations. This is not referring to binary addition. Network addresses identify a single network. A subnet mask is used to determine which portions of an address are reserved for the subnet portion of the address. Now, broadcast addresses identify all hosts on a particular network. Usable ranges identify the range of addresses permitted for hosts on a particular network. Please note, as I said here, subnet masks use to determine which portion of the address are reserved for the network. Another summary table. This one's very useful. To find the network address, given an IP address and a subnet mask, you would perform a bitwise AND operation on the IP address and subnet mask. To find the broadcast address, given a network address and a subnet mask, you would convert all host bits to 1. To find the usable address range, given a network address and a broadcast address, you would flip the last host bit in the network address to 1 to give you the first host, and you flip the last host bit in the broadcast address to 0 to give you the last host. With regards to ARP, if host X is attempted to communicate with host D in a different subnet, then host X should ARP for its default gateway, Z, then address the frame to the Ethernet address of Z. Summary 5. With regards to ARP, if host X is attempted to communicate with host Y in the same subnet, then host X should ARP for host Y, then address the frame to the Ethernet address of host Y, because it's in the same subnet. Thank you so much for your attention to this video. I hope you enjoyed it.